Hi, I'm Adolph Oliver, and this is a video clip about what's known as function composition. Now, this is really just another substitution method and something which you'll be using from time to time when you work your way up higher in math. Anyway, what we're talking about here is you're taking and substituting one function into another. Okay. Now, we have done such substitutions before when we were solving systems of linear equations and things like that. So this again is just a shorthand notation which can indicate what needs to be done without spending a whole lot of words doing it. A quick example here. Let's say f of x equals 3x plus 5, and again you know this is a function definition because this is an equation. G of x equals x minus 1. Now we want to find f composed of g. Let's put this down here. F composed of g. Now it kind of darkened in here, but what this is really right here is an open circle. There we go. So this looks like it'd be fog, but it's not. This again is f composed of g, and we're leaving the x's in it because we have the x out here. Remember, the reason we always have this is to indicate whether we're plugging in some number or we're keeping the x. Well, anyway, here's how it works. It's very simple. You want to remember that the second guy always gets plugged into the first guy. So write the first guy, here he is, f of x, but leave a big hole for where the x is. So here it is, 3 and in parens plus 5. Now, what are we plugging into this first guy? What the second guy is, x minus 1. So that's why the x minus 1 is here. And then of course we go ahead and clean it up, and this is what we end up with. So we'd say f composed of x equals, in this case, 3x plus 2. Well, let's look at some examples. And again, before you can do any of this composition business, you've got to have the functions you're going to be using defined for you. So here is h of x equals 4x minus 4. G of x equals x squared plus 5. Now again, how do you know this is composition and not multiplication? Here you see it done a little bit better. The composition notation is a small little circle like this. So this would be verbalized h composed of g, and we're keeping the x's in it. So simply what we're going to do is take and plug the x guy into the h guy. So here we go. Write the h guy, but you see what a variable is? Leave a big space there to put the other function in. So 4 times, and instead of x I make a big set of parens here, minus 4. So that's the h guy. Now the second guy, the g, is getting plugged into it. So where the variable was, here we have x squared plus 5. Okay, well, this is real simple. Just clean it up. I've got 4x squared, distribute the 4 to the 5 plus 20 minus 4. Looks like we've got 4x squared. What's it going to be? Plus 16. Okay, there it is. That's what h composed of g equals when we have h and g defined like this. Well, once you see how this goes, these guys are easy to work with, and there will be, like I said, cases where you'll make use of these in the future here. So it's something that we want to pick up. Okay, once again, now notice we've got the g and the h guys defined. They're different from what they were up there. And notice that the order's different here. Again, we notice this composition because we see that open circle. So always be on the lookout for that. That's not multiplication. Multiplication would be a solid black dot. This is an open circle, which means composition. And the second guy always gets substituted into the first. So start by writing the first guy. We got -4, the variable is n, so I make a big hole for the n. And now what's going in and replacing that n? This whole function. So it's -4n plus 4. Okay, here it goes. Okay, so h gets plugged into g. That's what we did. We had the original g function. Where the n was, we replaced that with what h equals. Now just clean the thing up. Remember, we got to distribute in here. So -4 times -4 is going to be positive 16n. Okay, and then let's see, what do we got here? -4 times +4, -16. So there we go. G composed of h. Notice we got the n here, so we're leaving the variable in it, is 16n minus 16. Here are a couple more examples. Again, we have the beginning functions that we're using defined. F of n equals this guy, g of n equals this. We see that it's composition. We got that open circle. So the second guy gets plugged into the first guy. So you start out by writing the first guy, and wherever there's a variable in the first guy, make a big hole to set of parents, because you're going to be plugging the second guy into it here. So here we go. This is going to equal 3 times, here's a hole for the n, minus 4. Now, what's replacing that n? The whole second function. So it goes in, and it's what? 4n minus 3? So here we go. Okay, well, now it's just a simple matter of cleaning this up. 3 times 4 is 12n. 3 times -3 is -9. And then we got -4, so combining the last like terms here, looks like we got 12n minus 13. Okay, again, not the most difficult thing you've done in algebra by any means here. Okay, here's another example. Again, the g function and the f function are defined. They're using the letter t here instead of x or some other thing. That's fine. And again, we see the open circle, so we know it's composition. But notice now, one additional thing going on here. We're not going to end up leaving the n in. What we're going to do is we're going to turn around and replace it with -1. But we have to do the composition first, then we'll substitute the value -1 in. So here we go. Again, the f guy gets substituted into the first guy. So we start writing the first guy. So this is going to be 2 times, here's a hole for the t, minus 5. Remember, you do this with the variables first, then the last thing we'll do is put the -1 in. Okay, what do we got here? Looks like it's t squared, t cubed. Here we go. Minus 5t squared. Okay, plus 1. Okay, now let's clean this up. Officially, what we're doing is we just found it so far with the variables. So distribute the 2 in. I've got 2t cubed minus 10t squared plus 2. 2 times plus 1 is plus 2 minus 5. Let's clean this up all the way before we substitute the -1 in. So we'll have 2t cubed minus 10t squared plus 2 minus 5 will be -3. Okay, now let's remind ourselves that what we want to do is not find it for the variable t, but find it for -1. Okay, so all the variables we're going to replace with -1. So 2 times -1 cubed minus 10 times -1 squared minus 3. Okay, well, negative 1 cubed, we got 3 minuses, so this is going to be negative 1 times 2, negative 2. Okay, negative 1 squared is positive 1. Positive 1 times negative 10 is negative 10. And then we have our negative 3. So what's the final value here? Assuming that we want to find it for a negative 1. We got negative 2 and negative 10. That's negative 12. 3 more. Looks like it's negative 15. Okay. Here's the last couple of examples. Like I say, you should be getting pretty good at this by now. We got the g of x and the f of x function both defined for us. We want g composed of f, so we know we always take the second guy, plug him into the first guy. So I start writing the first guy, okay, which is 4 times, now I'm going to make a big hole for the x here, okay, plus 4. Now, what am I substituting in for the x? Well, the whole second function, which is going to be 4x minus 4. Okay, well, there that is. Okay, now let's distribute the 4 in here. I get 4 times 4, 16x minus 16 plus 4. Okay, so let's see, let's clean this up. I've got 16x minus 16 plus 4 would be minus 12. Now, remember, we want to find this value for negative 9. So here we go. 16 times negative 9, okay, minus the plain number 12. Well, let's see. What's 16 times 9? I think it's 144, so I think this would be negative 144 minus 12 more. Looks like it's negative 156. Yeah, I think this is right. Looks good. Okay, there it is. Remember, we had to plug in that minus 9, but we had to keep the variables to do the composition first. Now this last one is interesting, but it works perfectly fine. You can turn around and compose a function with itself, and there are actually problems that you'd be solving in math that where you'd be doing something like this. So we only need to know one function, the f of x function, because that's the only one that shows up. And we're going to take f and substitute it into f. Okay, so here we go. Once again, starting out with the first function, negative 3, but now of course I make a set of parens for the variable. I'm going to substitute the second guy in, who happens to be the first guy. Okay, so negative 3x, and of course we want to find this again for a number, and the negative 9 shows up again here, but we had to keep the variables to do the composition first. Negative 3 times negative 3 is positive 9, so we had 9x here when we clean this up. Now, of course, let's substitute in. I got the 9 in front. The x we want to have negative 9. Okay, that's this guy right here. So what do we end up with? Well, 9 times 9 is 81. Looks like it's negative 81. Okay, well, composition is not that difficult to do.